Okay, chapter inferences from two samples. We are going to cover two different sections from this chapter, and we're going to use the sample means. And in first chapter of first section, the means samples would be independent samples, and then second section is two dependent samples. So our goal is to present methods for using sample data from two independent samples to test hypothesis. So we are continuing hypothesis testing, and in this section we are going to use two different samples. Okay, so independent. Two samples are independent if the sample values from one population are not related or somehow naturally paired or matched with the sample values. That's two samples are called independent, and they are called dependent if the sample values are somehow matched, where the matching is based on some inherent relationship. There is some kind of relationship. So our goal is to do the hypothesis testing, conduct a hypothesis test of a claim about two independent populations. Confidence interval, construct a confidence interval estimate of the difference between two independent population means. So I'm going to give you formulas first, and then eventually, instead of using those formula manually, I'm going to show you how to use your StatCrunch for finding information in this section. So these are the notation we're going to use. Mu1 population mean for the first population, sigma 1, that's the population standard deviation for the first, n1 sample size, x1 bar is sample mean, and s1 is the sample standard deviation. We're going to use a very similar type of notation for second population. So these are the requirements we need. The values of sigma 1 and sigma 2, which is standard deviation for two different populations, are unknown, and we do not assume that they are equal. That's our requirement. The two samples are independent, and then both samples are simple random sample, and either sample size for both samples are greater than 30, or both samples come from the population having normal distribution. So these are the requirement we need. Okay, and this is a t-value, test statistics. This is the formula for the test statistics we're going to use. And in the hypothesis testing, we always assume that the difference between the two population mean is 0. Okay, so these are the some more information, like the degree of freedom can be calculated by using this formula. As you can see that df stands for degree of freedom, smaller of n1 minus 1 and n2 minus 1. So typically we use the technology, even in StatCrunch, we don't have to worry about this formula. It's going to be calculated. We are going to use again for the hypothesis testing either p-value or critical values, and we also find the confidence interval to estimate the difference between these two mean. We have to find this value for finding the confidence interval, where E is the margin of error, can be calculated by using this formula. One more time, these are the formula you should know, or you can see here, but we can also use technology for finding this confidence interval. I'm going to show you how to do that. The p-value method of hypothesis testing, the critical value method of hypothesis testing, and confidence interval all use the same distribution and standard error, so they are equivalent. Okay, so these are the information you need. So let's look at some examples from this section. So first problem, determine whether the sample are independent or dependent. A data set includes the list price and selling price for each 120 randomly selected homes. So look at here, it's a list price and selling price. There should be always some kind of relation between them. So it's not independent. If you go back to the definition of independent, they should not be somehow naturally related, pair. Okay, the samples are dependent because there is a natural pairing between the two samples. The samples are dependent, that's another one, because there is not a natural. Okay, so this is the first one is the right one. That's the first one. Let's go to the next problem. Here is the problem we have given. Here is the data. As you can see, there are two situations. An experiment was conducted to determine whether giving candy to dining parties resulted in greater tips. The mean tip percentage and standard deviations are given in the accompanying table. So here, if you don't give the candy, then where the sample size is 29, the sample average or mean is 18.89 and standard deviation 1.43. This is the tip, okay? And then when you give two candies, the sample mean sample is greater than not giving candy. Okay, now we need to do the hypothesis testing. Let's assume that the two samples are independent, simple random samples selected from normally distributed population. So we don't have to worry about those requirements to fulfill. It's already given. So now, first of all, the first question is use a 0.01 significance level to test the claim that giving candy does result in greater tips. So mu1 stands for no candy, mu2 stands for two candies. Always remember, for the hypothesis test, mu1 should be equal to the mu2. So choose that option where mu1 and mu2 are equal. So there are three different options. And another option is our claim is, the giving candy does result in greater tips. So that means mu2 should be greater than mu1, or mu1 should be less than mu2. So this is the option we have, where mu1 and mu2 are equal for the hypothesis test, and alternating test is mu1 is less than mu2. Now, find the test statistics. As I mentioned earlier, for finding the test statistics, there is a formula. What is that? This one is the formula. You can do it manually. Just plug the value of this, sample mean, population mean, and then sample standard deviation and sample size. You can do it manually, or you can go here and you can just use a stat crunch. When you use the stat crunch, just go to the stat, click T stats, two samples with data. It's not data, it's a summary, so use with summary. And now plug the value of this summary here. The sample mean mu1, as you can see here, it's 18.89. Remember, you put the correct information. This is for mu1. Standard deviation is 1.43, and then sample size is 29. For the sample 2, the sample mean is 21.08, and the standard deviation is 2.57, and sample size is 29. One more time. And then if you go down here, rest, you don't have to worry about this option here. Hypothesis test for mu1 and minus mu2, this would be 0 always. And for this particular problem, mu1 is less than mu2, so this difference should be less than 0. Okay, and now if you go back to the problem, it says that use a 0.01 significance level. So 0.01 significance level, compute. So it gives you T stat. That means it's a test statistics here. The value is, where is the value? It's a negative 4.00, so it's a negative 4. If you round it to the 2 decimal place, it's a negative 4. Excellent. What is the p-value? You go back the same place and you see that p-value is 0.0001. If you round it to the 3 decimal place, it should be again here, it's a 0. Now, to make the conclusion after this, we have to go back to the section 8 point, the previous section where you have to compare the p-value with the significance level. In this case, if you go back here, the p-value is 0 and significance level is 0.01, so it's a less than significance level. So it's a less than significance level means reject the null hypothesis. So reject the null hypothesis. So there are two options to reject the null hypothesis. One is there is a sufficient evidence to support the claim that giving candy does result in greater tips. Here is the thing, before you choose one of these options, you have to keep in mind what they are saying. The rejection of null hypothesis means two averages, they are not equal, but it does not mean that mu1 is less than mu2 or mu2 is less than mu1. It could be one way or other. But to make the conclusion, as you can see here, from the sample mean from no candy is less than sample mean from the two candies. So that means reject the null hypothesis. There is a sufficient evidence to support the claim that giving candy does result in greater tips. Okay, because of this sample. Now, to find this, confidence interval, either you can use manually. You can find that you can use the formula, or you can again go back to this StatCrunch, and you can just go back here again. Stat. Okay, I had to use the same thing. To sample with summary. The very same thing. I was not supposed to cancel that before, but let's put it here one more time. It's what is that? It's 18.89, standard deviation 1.43, sample size 29, sample mean 21.08, standard deviation 2.57, sample size 29. One more time. Now, it's not hypothesis test. We are going to find the confidence interval, and to find the confidence interval, this label can be found by using a 1 minus 2 times the alpha, significance level. Here the significance level is 0.01. So to find this level, you just subtract 1 minus 2 times this value, which gives you 0.98, because 1 minus 0.02 is 0.98. Now, when you just hit this compute button, it gives you the lower limit for the confidence interval and upper limit for the confidence interval. These values are same. These values are same as if you use this formula for finding the lower limit and upper limit, and after finding the margin of error. But StatCrunch, it's going to calculate for us those things. So the lower limit is negative 3.5. So go back here. So round it to the 2 decimal place, negative 3.51. Negative 3.51. That's the lower limit. And then upper limit is it's a negative 0.87. Negative 0.87. So that's your confidence interval. So as you can see here, because this confidence interval is always negative, that means mu1 and mu2 would be always, if it's negative, that means mu2 would be always greater than mu1. So because of this confidence interval, does the confidence interval support the conclusion found with the hypothesis test? Yes, it supports, because it says that reject the null hypothesis because the confidence interval contains only negative value. Because it only contains the negative value, meaning if it's always negative, then mu1 minus mu2 is always less than 0. That means this is our hypothesis. That's the claim we would like to check. Let's go to the next problem. Very similar type of problem. We have given we have given data sets listed in the accompanying table. Here is the table. As you can see here, they have the different sample size, so that's not a problem. Okay, these are the weights of randomly selected US Army male personnel measured in 1988. So second one is 1988, and then first one is 2012. So now assume that the two samples are independent simple random samples. So they are independent and normally distributed. So it satisfies our requirement. Do not assume that the population standard deviation are equal. Complete this thing. So now, because we need to find out what is the claim. What are so use 0.05 significance level to test the claim that mean weight of 1988 population is less than. So if this is mu1 and this is mu2, then mu2 is greater than mu1. So our null hypothesis is they are equal, and our alternate hypothesis is they are mu2 is greater than mu1. So now to find the test statistics, you can copy this in the StatCrunch, and you can do the very same thing this time. Just go to the stat, tstat, to sample with data this time. This is not the summary, this is the data. So the first sample we're going to choose is it's from 1988. Remember, you have to be very careful. Mu1 we're using for population mean for 1988, and mu2 we are using the population mean for 2012. Okay, and now our hypothesis is these two values of the null hypothesis is the difference is 0, and alternating hypothesis is the difference should be less than 0, and our confidence interval given here is 0.05 significance level. So we are going to use that significance level here, and if you compute, it's going to give you the test statistics, which is negative 2.34. So negative 2.34, that's our test statistics. Okay, so the p-value, as you can see here, the p-value, what is that? P-value, it's given is 0.0151. So if you round it to the 3 decimal place, it's 0.015. That's a 3 decimal place. And finally, we have to make the conclusion. As you can see, that p-value is it's a less than significance level, right? It's a 5%, it's a 1.5%. So if you go back to our conclusion, p-value is less than alpha, so that means reject the null hypothesis. So reject the null hypothesis. The p-value is less than significance level here, so we need to reject the null hypothesis. And by using the StatCrunch, if you see here, the mean of 2012 is greater than mean of 1988. So that means it supports. There is a claim that the mean of 2012 is greater. So we can say that what is that? Reject the null hypothesis. There is sufficient evidence, that's the evidence coming from the sample, that support that the claim that mean weight of 1988 population is less than mean weight of 2012. Now for finding this confidence interval, we can do the very same thing here. We can use our edit the option here. Instead of hypothesis test, we would like to find the confidence interval, and as you can see here, the alpha value is 5%, then confidence interval we have to use 0.9, which is 90%. It gives you the lower limit, which is negative 22.1, negative 22.1, and for the upper limit it gives you negative 3.3, negative 3.3. So if you check that, you